Hello friends, this is Dr. Antoine, your coach in data analysis using R2. In this video, I'm going to show you how you can compare proportions when you have, for instance, one proportion you want to compare to a given standard or a given norm, or when you have two proportions you want to compare. In proportion tests, you want to compare one proportion to a given standard, or you want to compare proportions from two samples. What are the conditions, friends? Now, when you want to make a proportional comparison, the population sampling method must be random. A sample must be independent. In each sample, you must have at least 10 successes and 10 failures. What is the null hypothesis when you want to compare proportion? The null hypothesis is that the two proportions are equal. Now I'm going to show you how you can make hypothesis testing on proportion. This is the comments. Now this X here is the number of successes in your sample or your data set, and this N here is the sample size, and this is the P here, the value you want to test against. We want to test whether the proportion is significantly different from 0.25. This comment, this is the number of success having the characteristic you are interested in, and this is the number of sample, and this P here is the standard proportion or standard norms. You want to compare if this proportion is equal to this standard or this norm. Okay friends, now let's learn this test, and you will see this is what we call a two-sided test, and you will see the significance level. You must know that the significance level may be 5%, and when we found that the p-value is greater than 5%, we do not reject the null hypothesis that the proportions are equal, and when the p-value is less than 5%, we reject the null hypothesis that the two proportions are equal. Now look friends, this is comparing one proportion to a given standard or a given proportion. Let's run these comments. This allows me to have values in numbers, not in standard scientific formula. And let's run these tests. You will see the p-value. Here, this is the chi-square. This is the value, and this is the degree of freedom, and the p-value, as you see here, is less than 5%, and as you can see here, this proportion here is the proportion here is 0.166, and as you can see, we said that the null hypothesis is that the proportion is equal to, these proportions are equal. 0.16 is equal to 0.25, and as you can see here, the null hypothesis was rejected, and we can conclude that these proportions are significantly different, and you must indicate this statistic and the degree of freedom and the p-value. And also we can use what we call one-sided tests, and here we can indicate whether it is greater or less. Let's run this test to see whether this value, this proportion, is less than this one, because the proportion here is obtained by taking this 2050 divided by 1500. This is the proportion we are talking about. This is the proportion, friends. Okay, now let's use the one-sided test to see whether this proportion is less than this one. Let's clean this. Now, as you can see here, friends, the null hypothesis was rejected. The null hypothesis is this percentage, this standard we are comparing to this one is less than this proportion, this proportion. The null hypothesis here, as you see here, is rejected, and we can conclude that 0.25 is not less than 0.16. This is what we call one-sided test. And you can test whether this proportion is greater than this one. When we say greater, we use this greater. Now, as you see, let's pin here. Look, friends. Now, as you see here, the p-value is greater than 5%, is 1. That means the null hypothesis that 0.25 is greater than 0.16 is not rejected, and we conclude that this proportion is greater than this one. Okay, friends, this is how you can compare one proportion to a given standard. And let's show you how you can compare two proportions. Now here the null hypothesis is that the proportions are equal, the same null hypothesis. But here we have, for instance, we have this is the success for this sample, and this is the success for this sample. Okay, friends, this is the success in this sample, and this is the success in this sample. And we want to compare to see whether these proportions are equal. Suppose that we conducted a market survey and we found that, for instance, this population is against the product, and this one is and this one agrees with the product in this sample. And we want to know whether the proportions of those who are against and those who are for the product are those proportions are equal. And we use this test, friends. As I said, this is the number of success and in this population, and this is the number of success in this population, and we run the test to see whether there is significant difference in these proportions. As you can see here, friends, this is the chi-squared, and this is the calculations of the test, and this is the degree of freedom, and this is the p-value. As you see here, friends, the p-value is less than 5%, and you conclude that these proportions are not equal. Because when you see here the proportion here, we have 0.20, and here we have 0.25. Now 0.20 and 0.25 are statistically different. Now, as you see here, friends, 0.20 and 0.25 are statistically different. Now, when you want to report, we conclude that the proportion of sample is significantly different in the two groups, and we report these statistics and the p-value. Now, when we want to use one-sided tests, we indicate whether it is a great alternative here, whether it is less or great. Look, friends. As you see here, the p-value is less than 5%, and we conclude that this proportion, this one, is not less than this one. When we use greater, for instance, we will see that the p-value will be greater than 5%. And look here, friends, when I run this test, this one, look, friends, as you see here, the p-value is greater than 5%. That means this proportion is greater than this one. That is what it means. Okay, friends, I think this will help you to understand how you can use proportion comparison when you are making your studies. And if you like this video, you can share it and comment it, and you can also subscribe to our channel. Thank you for watching this video. For next video, bye.